Hello, everybody. Welcome to another presentation. Today's topic is database design and classification. So, let's talk about classification of database systems. So, database management systems are broadly classified based on three criteria. First one being the type of data model used to store the data. Second being the number of users that the database system can handle. And third being how the database system is distributed. So classification based on data models. So this a database system can be classified based on the approach it chooses to store its data in the database. So we can have a relational database wherein we store data in tables, an object oriented one, a hierarchical one wherein data is stored in the form of a tree, or a network database wherein is stored in the using a graph. So moving on, classification based on number of users. So any database management system can be classified based on the number of users it can support. So a single user or a multi-user. An example of a single user database management system is Microsoft Access. Multi-user PostgreSQL, something like MongoDB. Moving on, so database management systems, they can be classified based on date how the database systems are distributed. There are two main distributed database systems. First, being the centralized database system. Herein, the DBMS and the database both are stored at a single site that is used by several other systems too. Second, being distributed database systems. Now, these are actually subdivided into homogeneous and heterogeneous. In distributed systems, the actual database and the database software are distributed from various sites that are connected by a computer network. So, homogeneous distributed systems, all the sites are using the same database software. And in heterogeneous, different sites may use different database software, but to facilitate interaction and data exchange between various sites in the network, there has to be a common layer has to be introduced that can change the data to some common format that each database system can read. Moving on, let's talk about database design. So why are database designs important? They provide a blueprint for how the data is going to be stored in the system. So database design can be defined as a collection of tasks that enhance the designing and maintenance of the database systems. You could also define it as a mapping from the conceptual model to an implementation model of a database. Now let's talk about why database designs are important. We'll take an example of some businesses which rely heavily on data to make informed decisions and drive the operations. So behind the scenes, we need an effective database design to ensure that the data is correctly managed, it's stored accurately, it is consistent across various systems, and hence we need an effective database design. Also, a good database design clearly conveys the behavior of any application and how the queries are processed. If the constraints of an effective database design are properly implemented, the processing time for an application using that database is greatly reduced. Moving on, what are the phases of a database design? So, phase 1 is collection and analysis of user requirement. Phase 2 is the conceptual database design. This is actually where we map the conceptual data design to the logical database design. Okay, so the third phase is the choice of the type of database system used. So we discussed the types of database systems over here, so like based on data models, number of systems, distribution. The fourth phase is the logical database design or data model mapping, and the fifth phase is the physical database design. The sixth phase is implementing the database system and tuning it. We'll discuss about what tuning is later on. So let's what actually entails in phase 1 is that we identify who the users of a database are going to be and their requirements. Now this is a very important step because we need to know from the get go what who the users are going to be and what their requirements are. and it's also a very time consuming step. In step 2, we produce, or phase 2, we produce a conceptual schema of the database, that system that is independent of any specific database system. So conceptual database design, phase 2, it involves two activities which are conducted in parallel. First being the conceptual schema design, and the second being transaction and application design. So what happens in the conceptual schema design is that we identify entities, attributes and relationships in the real that accurately reflect the real world scenarios. And in the transaction and application design, we include operations in the transactions, inputs, outputs and processing steps to ensure data integrity and efficiency, creating use cases, identifying the functional requirements of the database system. So, what are the approaches to a conceptual schema design? The steps that we discussed here, right? So, conceptual schema design. What are the approaches? First being we use a centralized schema design approach, and the second being a view integration approach. So, what is done in sorry. So, what's done in centralized schema design is that requirements of different applications and user groups are merged into a single set of requirements, and a single schema is designed. And in the view integration schema design approach, the schema is designed for each user group or application, and then these schemas are merged into a global conceptual schema during the view integration phase. Okay, so sorry for the. Alright, so let's discuss what are the various strategies for schema design. So we have four. First being top down. Herein we start with a high level abstraction of the schema, and then as we move from the top to the lower layers, we apply refinements, so they become less and less abstract. In the bottom up approach, we begin with something that is very minimally abstracted, a schema that is very minimally abstracted, and then we combine multiple such schemas to create more abstracted um, layers. So we move from the bottom to the top level of the abstraction. So like this is the least amount of abstraction, we are moving to the top. Then in inside out, we start with a central set of concepts and then spread outward, like considering new concepts in the vicinity. There's also a mixed schema design. This is actually just a combination of top down and bottom up. Now, moving on, let's talk about the third phase in the database design, which is the choice of type of DBMS. Now, to choose what type of database system we are going to use, we need to consider many factors, like the type of data model that will be needed, the storage structures that we would use, maintenance, acquisition, is it easy to acquire the data, will it be feasible to maintain it in the long run. So, this is an important phase because it will determine how a database system will be moving forward. So, in the fourth phase, which is logical database design, here is where we map the conceptual schema that we came up with in phase 2 to the data model that we chose in the phase 3. Moving on, in the fifth phase, that is physical database design, we design the specifications for the stored database in terms of like what physical storage structures we will use, record placements, and indices. So this corresponds to designing the internal schema in the terminology of the three-level database system architecture that we saw. So like tier 1, tier 2, tier 3, that kind of thing. Centralized, database systems are on the client side, server side, and application layer. The last, the last step, the last phase of database design is implementation and testing. So during this phase, the database and application programs are implemented, they're tested, and eventually deployed for service. Now, during this phase, various transactions and applications are tested individually and then in conjunction with each other. it it also reveals this phase also reveals a lot of opportunities for database tuning. So what is database tuning? It is an activity that is conducted throughout the life cycle of the database. It is basically regular maintenance of the database, improving it. So what we do is we check for physical design changes, data indexing, different placement of data, so that kind of thing. And then we tune. By tune, what I mean here is we make some changes to the database design as in, as how we see fit. So that is all. Thank you.